Okay, well, thank you, Daila. And our next session is looking at Africa, and we'll start with Dr. Ryan Blumenthal, who's a senior specialist forensic pathologist and associate professor at the University of Pretoria's Department of Forensic Medicine. His chief field of interest is the pathology of trauma of lightning, also known as coronal His book, Autopsy, Life in the Trenches with a Forensic Pathologist from Africa, became a nonfiction bestseller in South Africa. His 8-part documentary, Lightning Pathologist, was viewed by over 2.2 million people. Dr. Blumenthal, I hand it over to you.
Thank you very much, and it's a great honor to be here and see all the friendly faces of the lightning community around the world, and I think this is a great initiative. So without further ado, Dale, you'll be in charge of my slides, is that correct?
Yes.
Right, then we may proceed. So the title of my talk is One Storm, Two Deaths. I need to give a trigger warning, please, because I am a forensic pathologist and I am systemically desensitized to what I see, but this may be somewhat unsettling for those that aren't exposed, but I have tried to be as sensitive as possible with what I'm about to show you. But on the 2nd of March, 2024, in Pretoria, South Africa, there was a thunderstorm which killed 2 people. And I attended both these scenes. They happened on either side of my town or city. And I would like to show you the scene investigation and autopsy results of these findings, so we may proceed. So just to summarize what you're going to see, on the 2nd of March 2024, a thunderstorm moved through Pretoria from east to west. 2 people were killed during that thunderstorm, a 19-year-old male from Mamelodi East and a 30-year-old female from Olivenhout Bos. The 19-year-old male was killed by direct lightning strike, the first mechanism, and there were signs of corona pathology on his body. The 30-year-old female was killed by side flash, that's the third mechanism. She was wet from rain, and there were no signs of corona pathology on her body. However, both victims showed signs of lightning damage on their clothing. The forensic importance of a meticulous clothing examination is highlighted, and the importance of lightning safety is also highlighted. So to kick off, we're going to begin with the first case, which happened in Mamelodi East. If we can just show you the next slide, please. The scene was a bridge top, and the deceased was playing football on a soccer field, which is close to the mountain. And if you go through the next few slides, you can see how he came up on a walkway. This is the area where he was killed. This is just looking around. But the next slide, you can see that there's like a walkway that goes down, and he was coming up from that walkway. All right, next slide, please. So that's the way the path goes down. Next slide. This is exactly where he was found dead the following day. You can see there's like a mark on the ground where he was found dead. And a meticulous examination of the scene showed, if you look at the next slide, there was some singeing of plant material in the vicinity. So there were some dead leaves close by to the body. Next slide, please. We did a lightning detection network survey of the region, and there were 4 strokes in the region. So this was highly likely in keeping with where this incident occurred. Next slide. We x-rayed the body. There was nothing internally on the body that could be seen internally on x-ray. Next slide. And you can see the dramatic features of lightning on the clothing. If we can go through the next few slides, you can see that the shirt, the jacket, the tracksuit pants, the sneakers, all were damaged tremendously, the socks by lightning. So this was in keeping with direct lightning strike. Next slide. The socks were torn and tattered. The tracksuit pants were torn and tattered. And even the underpants were torn and tattered. That's the jacket also. And the t-shirt torn and tattered. On the body itself, the whites that you see around the neck, that's Parthiv versicolor, which is like a fungal infection that has got nothing to do with the lightning. But the long streaks down the midline of the body, that's due to lightning. The longitudinal streaks there. Moving on. You can see longitudinal streaks down the midline of the body. That's the lightning, carry on. Even down the back, you can see the singeing and the scorching of lightning, carry on. Even down the leg, you can see the signs of lightning, singeing of the hair. Next slide, please. Nothing on the feet. There was no tiptoe sign. That's the 1 foot. And the other foot, Dale, if you can just show the other foot, there was nothing on the feet. So to summarize this case, it was direct strike, first mechanism of lightning. And to summarize this case, if I can just have the next slide, it was an adult black male with torn and tattered clothing. There were longitudinally orientated scorch marks which were present chiefly on the left side of the neck, anterior midline of the trunk, posterior midline of the back, and posterior aspects of the left lower leg. There was a tongue bite mark on the right tip of his tongue. An internal organ examination only showed petechiae within the fissures of the lungs and the anterior aspect of the epicardium of the heart. Next case, please. So it was in keeping with direct lightning strike. May we move on to the case from Olivenhout-Bos? So I went to this scene the following day. It was under an exotic tree, and the scene was quite haphazard, but we did careful examination of the scene. If you can please move to the next slides. This tree would look innocent to a passerby, but careful examination of the tree. If you take a look at the next slide. Okay, carry on, please. There was some stripping of bark. It was very subtle. Move on, please. I found a sneaker at the side with some melting of rubber. Next slide. There was a hairpin with some melting also on the scene that must have been blown off at the scene at night. And on the other side of the tree, there was some stripping of bark. And if you take a look at the next slide, you can see that there was a linear line moving down the tree. Okay, this made me think of the third mechanism of lightning injury. She was standing under the tree seeking shelter. Next slide. Once again, stripping of bark off the tree and some stripping of the bark well away from the scene, within about 10 meters. Next slide. This was the lightning network detection, and it was in keeping with the region of the tree. Next slide, please. Once again, an X-ray showed nothing internally on the body. There was nothing untoward on X-ray examination. And then at the scene, at autopsy, once again, clothing damage, melting of synthetic fibers. The scarf, there was damage. We can keep moving, please. You can see this singeing of the fibers of the synthetic blue shirt. Nothing on her body. She was wet. There was not a single finding externally on her body, which shows you if you don't look at the clothes or if you don't know the history, you can be fooled. Next slide, please. Next slide. That's the scarf. Next slide, please. There's the other sneaker with some melting of rubber. All right, next slide, please. There's some singeing of this garment. You can see on the bottom right there. Singeing of the underwear. Singeing of the blue shirt. No injury to the hair. There was no singeing of hair. There was just grass in the hair. And there's, once again, tearing and tattering with on the upper aspect of the scarf. You can see that. So this was the third mechanism of lightning injury. It's almost like a side flash where discharges off the tree onto the person. So to summarize this case, it was an adult black female with torn and tattered clothing, chiefly on the left side of her body. External examination showed no injuries on the body. Internal organ examination showed no injuries or abnormalities, although there was fluidity of the blood. The blood was dark and fluid and oozed from the ventricular chambers. And as I said, the history was that she was seeking shelter under a tree. So to summarize the last slide, this was in keeping with the lightning strike third mechanism. And the LDN data showed stroke detected, reported very near to the location of the bodies. These reports are very likely the events in question. And from the SA-LDN data, it appears that both events were multiple stroke flashes. Peak currents were greater than 15 kiloamps for all strokes. That was with the assistance of Dr. Hunt, Prof. Hunt, Dr. Hunt. And then just to round off here, so the 19-year-old male was killed by direct lightning strike, first mechanism, and there were many signs of corona pathology on his body. The 30-year-old female was killed by side flash, third mechanism. She was wet from rain. There were no signs of corona pathology on her body. However, both victims showed signs of lightning damage on the clothing. So the importance of careful clothing examination is reiterated. The forensic importance of clothing, or the pathology of clothing, cannot be underestimated. And once again, the importance of lightning safety is highlighted. And then as a last slide, I requested, if I may just mention this, but I requested Dale Zhang, if I could put the slide down. But next year, 10 to 13 March 2025 in Pretoria, we are going to be hosting the biggest forensic conference on the African continent. The website's ASFM 2025, you'll find it. But if anyone wants to attend, please register. You would be welcome. We've got stellar keynote speakers. And thank you for your time.
Thank you, Ryan, for the presentation. Really appreciate the work that you're doing to better understand lightning injuries and lightning fatality mechanisms. If there are any questions, please enter them in the chat. Otherwise, we can move forward. Seeing no questions, we'll move on to our next presentation, which is looking at preliminary results of the African Lightning Injury Reports database since 2018 with a couple of students, Isabella Sanford and Parthiv Dev. They are both at the University of Maryland, and they're doing work with Dr. Daila Zhang in various aspects, and majoring in astronomy and physics for Isabella and information science for Parthiv. So the floor is yours.
Hi, so we're doing the preliminary results of our African Lightning Injury Reports database. My name is Parthiv Deb, and
I'm Isabella Sanford.
we're led by Dr. Daniel Zhang, and I just want to thank the students, reporters, and AFCANET staff for collecting and archiving this data set. Next slide. So our introduction is our goal is to analyze lightning events across Africa using the AFCANET database. It is currently the largest database for information on lightning strikes in Africa. We have nearly 800 reports from 40 plus total countries. Analyzing these reports allows us to gain insights into what steps can be taken to prevent more deaths and injuries, as well as identify any patterns that may exist between these events.
So far, we have actually analyzed around 350 reports from 25 countries, so we're about halfway through the database currently. These reports can range from local news reports to submissions from citizens and even doctor reports. So for each of these, we collected as much essential information as possible, so date, geographic region, number of deaths and injuries, and whether those involved were male, female, and any other significant pieces of information. So with all of this, we were able to organize the data in meaningful ways. And as we can see on the right, we were actually able to show all of the different locations where these events have occurred. Go to the next slide. For data selection, there are some key points here. So some reports had no information about the date of the event, whether the people involved were male, female, whether children were involved, or the location of the event. So therefore, any statistics using this information are dependent on the reports that did. We also did not include deaths and injuries due to flooding or other storm events, only those directly caused by lightning strikes. And we only used data from human deaths and injuries, so animals and livestock were not included. Okay, next slide.
Okay, so as you can see in this bar graph, the red are women and the blue are men, and so these are deaths by gender and by each country. I know some things I've seen. For example, for Egypt, the number of deaths is significantly higher compared to other countries with 38 for both genders. Kenya also had a high number of deaths with with both genders losing 35. Uganda also had 30 for men, and 25 for women. And Zimbabwe had 25 for women and 20 for men. So did Yemen. Countries such as Burundi, the CAR, Chad, Congo, Eswatini, Gambia, Guyana, and Ivory Coast had significantly lower death counts. I think it's because East African countries like Kenya and Uganda have higher death rates compared to Central African countries because of geography and weather. As you can see, the highest number of lightning cases happened during the evening with 75. The lowest was in the morning at 15, while the mid round was at 35 for the night. This is because of factors like daytime heating, atmospheric instability, moisture availability, air mass convergence, and changing wind patterns that make it more likely during the evening.
We can also look at how these events are distributed throughout the year, as well as total deaths and injuries for each country that we've analyzed so far. So when we look at this figure on the left, we're able to see kind of what we expect. During the summer months in Africa, there are significantly more events than during the period of May to August. So from August to December, we see a pretty steady increase in the number of events per month, going from just over 10 events to more than 60. And from January to April, we consistently see about 30 to 40 events per month. And then looking at the table on the right, we need to consider a few things. So first, it's clear that some countries have significantly more deaths and injuries than others. This could be due to the fact that some countries do not have as many reports for lightning events. And additionally, these numbers are approximate. So sometimes we would have conflicting reports where, there was a report that said one thing about the number of deaths and injuries, and another report said something different. So when this occurred, we would only include one report, and we would choose the one with more detailed and credible information. So if we look at something like Egypt, it has the highest death toll out of all of these countries, but this was actually only due to one event, which I will discuss in a moment. So these numbers do not necessarily indicate the number of events per country. And so halfway through this analysis, we're seeing upward of 1,000 deaths and injuries. So we're obviously seeing the necessity to implement systems that can reduce the deaths and injuries due to lightning strikes. Go to the next slide. So we define unique events as events that have 20 or more deaths and or injuries. So as I previously mentioned, the largest event was actually in Egypt in 1994. There were 469 deaths due to lightning striking a fuel storage tank, and it essentially burned a village. And then in Kenya in 2020, we see a situation where 3 students were killed and 27 others when lightning struck a school. And in the Democratic Republic of Congo, there were 26 deaths and 24 injuries when lightning struck a power cable, causing it to fall onto houses and a market below. So these events exemplify the need for lightning safety, and in particular, we're seeing cases where lightning causes deaths in schools, and that's actually the reason that ILSD is a thing. So we need to continue studying these lightning events. And thank you. Are there any questions?
Thank you for that outstanding presentation. Or if there are any questions, please enter them into the chat. I'll start with a question, and you may not know, which is okay, but in a lot of places you see about a 9-to-1, 10-to-1 injury to fatality ratio for lightning, but it was much closer to a 1-to-1 there in the reports that you found. Do you think that injury reports are being underreported, or is there a higher incidence of fatalities, maybe because of a lower standard of healthcare in Africa? Or is there some other reason for that?
I would say the second one, because even though you could say somebody got injured from the lightning itself, you wouldn't know, they could die from the because of reason caused by the lightning and not immediately because of the low access to healthcare in Africa. So I think your second reason is probably the reason why.
Yeah, I can add on to that a little bit. A lot of the reports I went through, there were instances where someone was struck by lightning but actually passed away in the hospital. So not necessarily immediate death, but still as a result of, inadequate healthcare.
Okay. Thank you. If there are no other questions, then we can move on. We've got a panel discussion coming up next, and
Chris,
Sriram. Yeah, Marianne.
Yeah, this is Marianne. Just because somebody dies in the hospital doesn't mean it's poor medical care. They were transported to the hospital. They may or may not have had any significant resuscitation. But sometimes you can't convince the family to pronounce the patient dead, even though when they're brain dead, but they're on a ventilator for 2 or 3 or 4 days. Okay. The proximate cause was still the lightning event at the time of the injury, but they may have had just enough life signs to get them to the hospital, but they were going to die anyway. So it's not necessarily because of poor medical care. It may be because of poor medical care at the scene, but not if they survived long enough to get to the hospital. There's a better than 90% chance they were going to die anyway, just from the lightning, not necessarily because of poor medical care. Okay. So, in my experience, anyway, as a doc.
Gotcha, Deb. That's probably also correct.
Thank you.
Okay. Thank you, Marianne. And up next, we've got a panel discussion that will be moderated by Sriram Sharma.